So we want to consider power set. What is power set? Power set is the set of all possible subsets. Is the set of all possible subsets that can be formed from a given set. Suppose we have set A equals, let's say, A, B. This is a set. This set has two members, meaning cardinality of this set is 2. Now, and I define power set of A now as the set of all possible subsets that can be formed from A, from the members of A. Now, how do you know the subset that can be formed from this set? Number 1, for any given set, the automatic subset of that set is the set itself. That is, this set A is subset of itself. That is when we have improper subset under the type subset of a given set. So now, meaning the automatic subset of A now is A itself. So number 1 among the subset is A itself. So this time A is improper subset. Now that is number 1 among the subset. The another automatic subset of any given set is empty set. Empty set is automatic subset of any given set. So now number 2, empty set. Now the next one is you try to form subset from this. How do you form subset from this? I can form a single set of A. This is subset. I can also form another set with B. This is also what? A subset. Now, is there any other we can form? If you combine the two together, we have this set A. If you are not taking any of this, if any of this is not taken, we have empty set, which is this one. When you take one, you have this. When you take this, you have this. Now, it means how many subsets do we have now? We have 4. 1, 2, 3, 4. So now power set of this set A now equals to the power set, which is PA, of this set will now be set of all possible subsets, which is now A, B, empty set, and set A itself. So these are the possible subset of set A, and that is what we mean by power set. Set of all possible subsets that can be formed from a given set. Now, another thing is the number of elements, the number of members of a power set is given by this formula. That is the cardinality of members of a power set. Here now you can see now how many members do we have inside this power set? 1, 2, 3, 4. So we have 4. So, but there is a general formula. The general formula is this. So the n of your power set is given by 2 raised to the power of n. This n of means cardinality. So now it's given by 2 raised to the power of n. Your n is just an integer, is a subset of natural number. So now this n represents the number of members in that given set. Look at this set A. We have 2 members, Abby. So now this has 2 members, meaning your n equals to 2. Now when we say 2 raised to the power of 2, what do we have? That is 4, and that's why we have 4 members here. So that's why we have 4 members here. So this is the general formula for the power set of any given set. So let's consider this example. We are to find the power set of this set. And from our definition, we said power set is the set of all possible subsets that can be formed from a given set. Now, it means all possible subset of this set A, set of such, is what we call a power set. And I said earlier that for any given set, the automatic subset is the set itself, meaning the first subset, power set of A now. So now the first subset of this set A is A itself. Is A itself. Another subset is empty set. So that is 2. Then another one is when you take each of these elements 1, 1. So set that contain X, another set that contain Y, another set that contain W, another set that contain Z. So now we have this. Then we consider taking 2 at a time. You know all the possible subsets. This Y is subset of this. W is subset of this. And you know when we say subset, subset is also a set. It's just that the members of a subset is less than or equals to member of the set itself. So you can see now 1. This is 1 member, so it's less. And when you have A, which is improper subset, is equal. And that is what we mean by subset. Now, another one is when you combine 2 together. So now let's do it this way. Let's take W and X at a time. So here is another subset. W and Y. So that's another what? Subset. Then W and Z. That's another subset. We move on. Now, let's take X and Y and X and Z. So X, Y is also a subset. X and Z. X, Z is also what? A subset. Now, we took 2 elements at a go. We have all these results. X and Y, X and Z. Now let's take Y and Z again. Y and Z is not there before. Now, when we have how many subsets now? We still have some to form again. Now, the first case, we consider the empty set. We consider the entire set. Now, we take 1 element at a go. We have all the subsets. We take 2 at a go. Now, let's increase the number to 3. So, we have WXY. WXY is also a subset. Let's take WYZ. WYZ is also what? Is also a subset. So WXY, WYZ. Then let's also take a XYZ, or is it there before? XYZ. So here is also a subset. WYZ, WXY, XYZ, XWY. So all this, yes, everything is complete, huh? WXZ, Abby? WXZ is also a subset. Then I think we are good. YWZ is there. Now, let's count all the subsets we have. Now, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now 16. So to confirm that you listed all the possible subsets, it should be by the formula to know the number of members of a power set. The formula is 2 raised to the power of n. Don't forget. So the number of members of your power set should be 2 raised to the power of n. And your n is how many members do you have inside that set? Here we have 4. So 2 raised to the power of 4. That's 16. Meaning all the members of this set are listed. And this is the power set of this set. So it's very simple. You consider the set itself, the empty set. Then you list all the members 1, 1. Later you take 2 at a go, you increase it to 3, then until you get to the given members of a set. And this is the solution to this.